In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Astro 30 here yet again with another electronics fundamentals video for you. Now, we've already looked at the positive or the plus V series pass regulator before, but just as a refresher, I've got it drawn here. We're using a Zener diode clamping regulator to control the base of this pass element transistor, which happens to be an NPN, to get a regulated voltage output. Now, remember that with this circuit, if this was say a 5.1 volt Zener, well, the output voltage would be probably more closer to 4.6 because of the drop of this transistor. Now, I haven't shown adding a simple transistor error amplifier in here to overcome that problem, but I will go back over that again in just a moment. But today, what we want to look at is the negative version of this circuit. So I've got the positive one here drawn, as I've said, just as a refresher, and it's pretty easy to convert this to actually look at the negative voltage supply in a bipolar supply arrangement. Now, we've got a resistor here which we can calculate its value by taking the supply voltage minus the Zener diode voltage divided by the current of the Zener, which is usually around about 5 milliamps, plus the desired current we want on the base. So the way I work it is, if we want roughly 10 mA here, then we use a value of 15 mA in the final calculation. That gives a resistor value pretty close to where it should be. So how do we turn this into a negative voltage regulator? Well, it's actually pretty simple. All we basically do is change the transistor to a PNP and we reverse the polarity of the Zener diode and of course the polarity of the supply rail. And the resistor value calculation is exactly the same. So say this was a 35 volt supply rail and this Zener diode was a 15 volt Zener, so we're making a plus minus 15 volt supply, then the resistor value here would be a roughly 1.2k, which would be about right. So how would we include an error amplifier to overcome the losses of this transistor like we did with the positive version? Well, let me just draw the schematic again for the positive version of this and then we'll discuss how we turn it into a negative one. And there it is there. Now, in the positive solution we've got a smaller signal transistor here. It can be like a BC547 in this case, and our pass element could be a BD139. And that will give us roughly an amp of capability on the output. Now, with this transistor, if both these resistors in the resistive divider on the output, which is sampling our output voltage, are the same, then this transistor is going to amplify the difference between here and here by a factor of 2. So in the end, if you use a 7.5 volt Zener, the resulting output should be probably slightly higher than 15 volt. Alright, that's fine for a positive going regulator, and this resistor value is based on a plus 35 volt rail. Again, you calculate this resistor depending on what your supply voltage is. If it's lower, then the resistor value is going to be lower. But as I said, this is fine for the positive version. Well, what about the negative version? Well, we need to make a couple of changes. Well, the circuit looks exactly the same, but that's all we do. This transistor is changed to a PNP. This one's also changed to a PNP, and it's in exactly the same polarity as the NPN was. It's just now that it's a PNP, and we have reversed the Zener diode around, and I've obviously reversed the polarity, and that's it. And this will operate exactly the same way as the positive counterpart will. So instead of positive 15 volt or a little higher, we'll get negative 15 volt or a little higher. So let's look at a breadboarded up version of this and test to see if this actually does what it says on the tin. So a short time later, I've got it all breadboarded up. It's up the back end here of the breadboard, past the center line. Ignore all this stuff down here, that's for something else, which I haven't actually covered. I've got my home-built lab supply sitting there. I've got one channel hooked up and they're both set to 17.5. That's a reason for that. That's to mimic plus 35 volts or minus 35 volts in this case. I've got my multimeter hooked up across the output of the circuit so we can see what the voltage is. So I'll just turn the load of my supply on. The circuit's hooked up. And absolutely nothing happened, probably because these leads are screwed. There we go. Oh, it's only minus 0.2 volts, which is not right. In the case of this circuit, I'm using a 5.1 volt Zener diode instead of the 7.5 presented, so I should be getting an output of 12, but I'm not. I'm also using a TIP42C instead of a BD140. It doesn't really matter, it's a power transistor. I've got the base collector resistor, which is the 1.2K soldered across the transistor directly. So I need to see what I've done here. Oh, I see what I've done. Oops. I've mistakenly put a 2.2K base collector resistor across that transistor instead of a 1.2K. That means that the resistor value is too high for the supply voltage now, so well, I could change it, but in the end this circuit is going to be used in a amplifier power supply to give me a plus minus 15 volt rail off of the plus 35, minus 35, or plus 40, minus 40 supply rail, whatever it is. So what I'll do is, as I've got the other channel already set up to mimic a total supply voltage of minus 35 volt in this case, I'll just connect the two supplies in series. Okay, both supplies are now connected in series, so I'll turn the first one on, nothing happens. Turn the second one on, nothing happens. Why? Alright, well the reason was because I had the two supplies connected back to back. In other words, I had the positive connected to the positive and the negative connected to the negative, and it's not going to do anything. So let's try that again. Turn the first one on, second one on, and there we go. We've got 12.1 volts minus, because I've configured my multimeter leads with the positive going to the negative output, so we can see that it's a negative voltage. Now if I increase the supply voltage on one side, not much happens. So if I can increase the other side, not much happens. It does jump up by probably 20 millivolts, but it is actually functioning as it should. So the little circuit is functioning. But how about if we load it? Well, as you can see, I've got a relay sitting up there in the background. That draws around about 44 mA. So we'll hook that up across the output and see if we get any voltage drop. So I'll just connect this to the negative. We get a slight voltage drop, but not much. So I'll disconnect it. We're probably losing, I don't know, I want to say 40 odd mA, 40 odd millivolt, maybe less. Yeah, about 40 millivolt we're losing, which is not bad. And considering what I'm going to be using this circuit for in the end, it's not really going to be that much of a loss, because a plus minus 15 volt supply rail is going to be used as a supply for a preamp, for instance, or a bunch of op amps. So in my case, if it's only like 2 or 3 op amps, it's going to be about 20 mA of current draw. So we're not going to see that much of a voltage reduction. And one final thing about this resistor we should probably calculate the current, because under the operation of the circuit that I've just tested, it does get quite warm to the touch. So to calculate what wattage of resistor we need here, it's the power equals the resistive voltage drop multiplied by the current of the Zener diode base junction. So in this case we've got 35 volts minus our Zener voltage, which is 7.5 in this case, gives us a voltage drop across that resistor of 27.5. We now multiply that by the estimated current. That's nearly half a watt. So you'd really want to put a 1 watt resistor there for the resistor value, not a half watt. Just keep that in mind. So anyway, I hope you guys enjoyed this video. It was a quick one. And if you did, please remember to go down below and like, comment and subscribe if you haven't done so already. And anyway, this is the Astro 30 saying see ya. Have a great day.